All right, welcome back. This is Chapter 3, Section 4, solving systems of linear equations in 3 variables. All right, so a linear equation in 3 variables is just like some of the other definitions that we've had. It's basically linear equations. And with 3 different variables. So a linear equation in 3 variables is like 3x plus 2y. And then another variable of 4z equals 10. So now there are 3 separate variables. A system of 3 linear equations, you basically need to have 3 linear equations with the same variables. All right, solution of a system of 3 linear equations, it has to satisfy all equations. So it has to be a solution for every single equation. And an ordered triple is just like an ordered pair. You're going to have an x, a y, and a z. All right. So the elimination method for a 3-variable system, that's what we're going to be using. You're first going to rewrite the linear system in 3 variables as a linear system in 2 variables by using the elimination method. Basically what that means is you're going to have something that's like 2x plus 3x minus 4y equals 10. You're going to have a negative 2x minus 1y. Sorry, that should be a y. Plus 2z. I don't know why I did that. Equals 4. And you're going to have a third equation. All right. You're going to have a third equation. So basically what you're going to do for step 1. So step 1. All right. This is going to be equation A, B, and C. So step 1 is to eliminate a variable from equation A and B. All right, so from 2 of the equations. Once you've done that, you do the same thing from either AC or BC. And you'll see that in a few minutes, because what'll happen is you'll end up basically canceling out all these variables for the most part, and then you'll have 2 equations, 2 new equations that are xy, xy, and then once you have that, step 2 is to solve the new linear system for both of its variables. Then you have basically an x, so substitute the value found in step 2 into one of the original equations and solve for the remaining variable. If you obtain a false equation, such as 0 equals 1, in any of the steps, then the system has no solution. If you do not obtain a false equation, but obtain an, I think the word's supposed to be identity, but we're going to say truth. such as 0 equals 0, then the system has infinitely many solutions. So you're going to have to be very, very patient and very, very organized. So let's take a look at example 1. Rewrite this system as a linear system in 2 variables. All right, so step 1 basically is you eliminate a variable from A and B, and then you eliminate the same variable from AC or BC. So looking at these variables, you're going to want to choose one. Which one do you think, which one looks nicer? Look at the coefficients. 4, 12, 2. Ooh, that's kind of a pain. 2, 5, 3. Oh, that's even worse. But 3, negative 1, 1. X is going to be a nicer one. So let's take a look first. Okay, remember, so this is A, B, C. I said basically do A minus B. Or I'm sorry, A plus B. Eliminate a variable from A and B first, but you could eliminate from BC. And if we do that right here, this is B and this is C. When I do the elimination, negative x over x becomes 0. 5 plus 3 is 8y. 12z minus 2z is 10z. 73 equals 1. Or 73 minus or plus 1 is 74. So that's one of my new equations. Looking at, I did BC. Now I need to do like AB or AC. And since this is already opposites, no, actually, let's look at this bottom one. Let's look at AC. So we're going to add negative 3 times the third equation to the first. The reason I chose the third equation is negative 1, that's nice, but then you've got 5, 12, and 73. That'll cause some multiplication nightmare. So 1, 3, negative 2, 1, multiplying that should be a piece of cake. So you're going to take the bottom equation, multiply by negative 3. So it gives me a negative 3x. Gives me a minus 9y. And a plus 6z equals negative 3. And now we can just look at the coefficient. 3x minus 3x becomes 0. Negative 2 with a negative 9 is negative 11y plus 10z equals 17. All right, so watch. What we've done is we now have 2 brand new equations. I have negative 11 All right. So now what you have is here's an equation. All right. So we have now, looks just like 3.2, where you now use substitution or elimination to solve again. But first you add negative 1 times the new equation 2 to new equation 1. So I don't know which one is equation 1 or 2, but you basically multiply, let's multiply the top one by negative 1. That means that becomes 11y minus 10z minus 7, or equals negative 17. And then I've got 8y plus 10z equals 74. So when I combine here, this here becomes 0, and altogether 11y and 8y, that's 19y equals, well, let's see, 74 minus 17, 57. When you divide by 19, I'm hoping it ends up equaling 3. So 57 divided by 19 is 3. All right, now I know one of my solutions. I know the y value is 3. I also know that this equation here is an equation that has y and z. So if I said 8 times 3 plus 10z equals 74, that'd give me 24 plus 10z equals 74 minus 24. 10z equals 50, so z is 5. Once you know y and z, plug into any of the original equations. X plus 3 times 3 minus 2 times 5. That's x plus 9 minus 10. That's x minus 1 equals 1. And x equals 2. So my solution is 2, 3, 5. That's how these are set up. So my ordered pair was 2, 3, and 5. Alrighty, so we got a long ways to go here. Let's keep plugging away though, and we'll see if we can't get done in a little bit. Let's get started on example 2. This one is with no solution. So if you go back to here, the steps, you should see that if you obtain a false equation, such as 0 equals 1, at any time during the work, the system should have no solution. All right, so let's take a look at these and decide which, looking at the variables, which one looks like the best variables to get rid of. And I'm going to probably say that for these, you could easily choose the x's, or you could easily choose the y's. And let's go ahead and choose, why don't we choose the x's for this, all right? So what we're going to do is we're going to look at 2x plus 4y plus 10z equals 14. And we need the second equation to be the opposite of that. So this is equation A, this is equation B, this is equation C. Add negative 2 times the second equation to the first. So negative 2 times the second equation. So if I multiply everything in here by negative 2, negative 2 times x is negative 2x. Negative 2 times 2 is minus 4y. Negative 2 times 5 is negative 10z. And negative 2 times negative 4 is positive 8. So just like regular elimination, you are supposed to now add or combine these equations together. Negative 2 with a negative 2 becomes 0. 4 with a negative 4 becomes 0. 10 with a negative 10 becomes 0. So your new equation is 0 equals 22. Because you obtain a maybe a false equation, you can conclude that the original system has no solution. All right, now with many solutions. So if false equation was many, anytime you get a true solution that's always true will be many solutions. So take a look at these variables. And I'm going to point out that right now, the negative 2y, a 2y, and a negative 2y, the y's for equation A, B, and C are the best choices because they're already opposites. So right here, the first equation, so equation A, adding it with the second equation, equation B, 2x and 4x become 6x. The negative 2 and the positive 2 becomes 0. And the 4 plus the 8 becomes 12z. So that's equal to 18. All right, let's look at the next one. See here 2 with a negative 2. Equation B and C, right? Look back at the original steps that I gave you. So you eliminate a variable from A and B. We did that. Eliminate the same variable from either A and C or B and C. So we're looking for this equation, for this example, at B and C. 4x is 8x. 2y, negative 2y, 0. And then 8 and 8, that's plus 16z equals 24. All right. We now have two equations. We now have 6x plus 12z equals 18. And we have 8x plus 16z equals 24. Now solve the new linear system for both of its variables. All right, this one can be pretty tough because 6, 8, 12, 16, both of those are pretty hard to make be the opposites. I'm gonna tell you that we're just gonna go ahead and multiply the top equation by 8 and the bottom equation by 6, negative 6, because we want these numbers to be opposites. Now that means there's going to be some strange or some larger numbers that we're going to have to work with. But 8 times 6 is 48x plus 96y equals 18 times 8, 144. Negative 6 times 8, negative 48x. Negative 6 times 16, negative 96y equals negative 6 times 24, negative 144. And when we combine them, that cancels, that becomes 0, that becomes 0, 0 equals 0. So because you obtain the identity 0 equals 0, and because that is always true, the system has infinitely many solutions. All right, describe the solution. One way to do this is to divide new equation 1 by 6 to get something. All right, so this is asking then what the solution looks like. For this class right now, everyone, don't worry about this part of your notes or of the answers there. All we're going to be looking at is, all you're going to have to do is say to yourself, is there no solution? If there's no solution, that means you're done. If there's infinitely many solutions, it means you're done. If there's one solution, you have to write the ordered triple, and then you're done. All right, so we're not going to be using substitution, so you can cross off example 4. What you would do for this, though, you would want to rewrite the equation You would want to rewrite the y equals x plus z. You'd want to rewrite it as negative x plus y minus z equals 0. And now you would use the elimination method. All right, so let's try some of these checkpoints. And actually 2 more problems and we'll be done. So, looking at the variables, I want you to pause the video and guess, or no, and say which variable you think is the easiest one. All right, so hopefully you have a guess. I'm going to tell you it doesn't matter which one you choose. You can always get rid of z, always get rid of y, or always get rid of x. For this situation, since you have an x, 2 positive x, and a negative x, that should be easy. Not easy. That should be already set up for you. You can take a and b, x minus 2y minus 2z equals 13. You can take negative x plus y plus z equals negative 9 and add them together. That becomes 0. This is negative y minus z equals 4. Now you have a new equation. Let's take a look at equation B and C now. You've got negative x plus y plus z equals negative 9. You've got x minus 4y minus 4z equals 21. And when you combine these, they're already opposites. So it becomes 0. Y, 1y minus, that's negative 3y. That's minus 3z equals 21 minus 9, that's 12. That is a new equation. Now that you have 2 new equations, negative y minus z equals 4. Negative 3y minus 3z equals 12. Now it's just again like 3.2. All you have to do is figure out what do you multiply the top equation by to make these coefficients be opposites. So this is negative 3. We want this to be positive 3. So you should have a multiplying by negative 3. My new equations now, 3y plus 3z equals negative 12. Negative 3y minus 3z equals 12. Let's add this up. 0, 0, 0. You come up with the identity or the true statement of 0 equals 0. When you see a true statement, you say infinitely many infinite solutions, and you are done. Take a look at this. See if we can't make it a little bigger for us. There you go. Pick which variable looks the best. Here's a 2, 4, 3. That might be tough. 1, 2, 6. I would say z or y are both a good variable to get rid of. So why don't you pick it? Actually, we're going to choose y. We're going to choose y. And we're going to label these A, B, and C. And I'm going to now look at this and say, look, negative 2 and positive 2. They are already opposite, so we're going to look at A and C. What's nice, since I saw that, I don't have to do any multiplying. Those cancel, and you have 5x minus 5z equals 5. That's interesting. Now, we need to get rid of, we have to choose either AB or BC. And I want to point out here, this is negative and positive. The sign for BC is already opposites. So, 4x minus 4y plus 2z equals 17. We have to multiply c to make this number here the opposite of negative 4. So 2 times 2 gives us the opposite of negative 4. Combine some like terms. That becomes 0. And this becomes 10x minus 10 10z equals 13. So I now have a new equation here and a new equation there. So let's rewrite them. Organization is going to be a very big thing for you to be successful. All right, so looking at this, we want these to be opposite of each other. I chose x just because it didn't matter. I multiply the top equation by negative 2. And the bottom equation stays the bottom equation. So I combine like terms, becomes 0, becomes 0, 0 equals 3. This is false. So you say no solution. All right, so we're going to try to do a lot of examples in class. These will be the problems that we try to do, but you need to make sure you try to do your guided practices. Good luck.